So they start and stop where the circle starts and stops. So our integral here is going to go from -4 to +4 because that's where our circle starts and stops. All right. So when I rewrite my integral, I have the integral of -4 to 4 of 4 times y squared would be the square root of 16 minus x squared squared. Now, I'm going to simplify my life a little bit by pulling the 4 outside, because I can do that, and then I know that this square cancels this square root. So I'm going to rewrite that as 4 on the outside with the integral of -4 to 4 of 16 minus x squared dx. Now that's something we know how to integrate. We can integrate that by hand, or we can use our calculators because calculators are fun. So I'm going to pull out my calculator, and I'm going to put this integral in. 4 times the integral from -4 to 4 of 16 minus x squared dx. And that gives me an answer of 341.3333. That is the area of this shape. All right, now let's do some concrete example work with number 8 on page 16. All right, number 8. Page 16. Last time I wrote page 19. I didn't mean to do that. All right, number 8 says find the volume of a solid whose base is bounded by the circle whose center is at the origin, whose radius is 8. Okay, so it says that our base is a circle centered at the origin with a radius of 8. So it goes up 8, right 8, down 8, and left 8. Now, I'm going to go ahead and write the equation for this circle because I know I'm going to need it. I know that this circle is x squared plus y squared equals 64. That's the area of my circle. Now, part A says that the cross section is a square. All right? So the cross section is a square. All right. Cross section is a square. And I know that that means that the area formula is side squared. So I got to figure out what my side is. Now, in the coordinate plane, this is the x-axis, and this is a point on the circle, and this is a point on the circle, and the circle kind of does like that in the x-axis, okay? So again, from this point on the x-axis up here is going to be my y value, and from this point down to here is going to be my y value again. So the side is 2y, which makes my area 4y squared. And where does my y come from? It comes from the equation of the circle. That's the y value. So I'm going to solve this for y quickly. Y squared equals 64 minus x squared. Y equals the square root of 64 minus x squared. So now I'm going to write my integral. My integral is going to go from -8 to +8 because I'm bound by my base of 4. I'm going to put that on the outside, make my life easy. Y squared is going to be all of this squared, so I'm going to get 64 minus x squared dx. And I'm going to plug that into my calculator. 4 times the integral of -8 to 8 of 64 minus x squared dx. And that gives me 2730.6667. That is with a cross section that is a square. Now let's do it where the cross section is an equilateral triangle. So again, we're still bound by that same circle. This is part B. We're still bound by that same circle. So our equation of our circle is still here. All right. But now we're looking at the cross section being an equilateral triangle. So I want you to imagine that this is still my x-axis right here, and that this is a point on my circle, and this is a point on my circle. So it goes like that. Again, the base of this triangle is going to go up y units and down y units. So the base of this triangle is 2y. All right? The base of that triangle is 2y. I know that my area formula for a triangle is 1/2 base times height. I know that my base is 2y. Now I have to find my height. Okay? Now I have to find my height. Now, equilateral triangles are very tricky. Remember, this is what an equilateral triangle looks like. All three sides are congruent, where this piece down here is your base, and this piece right here is your height. Now, an equilateral triangle is a 60-60-60 triangle. When you draw the height here, not only do you bisect the base, but you also create two 30-60-90 triangles. Now, you remember that 30-60-90 triangles have special properties. So this is our 30-60-90 triangle. And if you'll remember, since this whole base was 2y, that was y there and this was y here, this is going to be y right here. The height, which is this piece over here, is whatever y was times the square root of 3. That was that property of equilateral triangles. So my base of this triangle is 2y. My height is y square root 3. So my area formula becomes 1/2. The base is 2y. The height is y square root 3. Now, I'm going to go ahead and simplify all of that before I plug in what I know that y equals from up here. Okay, so for my 1/2 and my 2, those cancel. And then y times y is y squared. So I have y squared times the square root of 3. Now, this is what I plug into my integral. Okay, and my y, again, comes from up here. Y equals the square root of 64 minus x squared. That was from part A. So I'm going to rewrite my, my integral again. And again, I'm bound by the circle. So from -8 to +8 of this area formula, y squared, which would be the square root of 64 minus x squared times the square root 3. I'm going to simplify my life a little bit more, and I'm going to kick that square root of 3 out. So the square root of 3 on the outside of the integral. And then the square and the square root cancel of 64 minus x squared. All right. You will start to notice some patterns that go along with these. For example, you notice that this is always on the inside of our integrals. Did you see that? Always on the inside of our integrals. This number out here is the part that kind of changes. Okay, so your integral for these problems should be the same. It's the outside number that you multiply it by that ends up being different. And you'll notice that pattern, and you'll pick that up to where you won't even have to do all of this nonsense. You'll just be able to go right to the volume formula. So I'm going to plug this into the calculator. Square root of 3 times the integral from -8 to 8 of 64 minus x squared dx. And we get 1,182.4134. And that's our part B. All right, let's try part C. For part C, again, we're dealing with x squared plus y squared equals 64, which we all know means that y equals the square root of 64 minus x squared. For C, it says that we're dealing with isosceles right triangles, okay? So my isosceles right triangle looks like this, where this is a right angle. And again, pretend like this is the x-axis. So this point right here, this is a point on the circle, this is a point on the circle. So it looks like that. We know that this is going to go up y and this is going to go down y, so that the base of my isosceles right triangle is 2y. All right. So remember, this is still a triangle, so it's still 1/2 base times height. All right. Now, If this is the base, that means that we need to find the height here. Okay, since this is an isosceles right triangle, you know that this side is equal to this side, okay? Now, when you draw this height here with an isosceles right triangle, you split this bottom base into two equal pieces as well. So look what you've now created again. Take a look at this triangle right here. You've created another isosceles right triangle because this was a 45-degree angle. This angle up here was the 90-degree angle, and you've split that in half to make the other 45-degree angle as well. All right? So with a 45-degree angle there and a 45-degree angle there, that means that those two pieces are equal. So this piece right here was already y, and this was y, which means if this piece is y, this piece has to be y as well. So the base of this triangle is 2y, and the height of this triangle is y. So I'm going to plug both of those into my area formula. 1/2, the base is 2y, the height is y. Simplify my life a little bit. That 2 and that 1/2 cancels out. So the area formula for an isosceles right triangle is just y squared. Again, you will notice these patterns with each one of these. Notice what happens. Remember those formulas. Those make it easy for you. All right, so this is my formula for my isosceles right triangle. Again, I know that y is this up here, so I'm going to do the integral from -8 to 8, because that's what I'm bound by, of y squared, which is just 64 minus x squared. Plug that into my calculator. And I get 682.6667. All right, now let's do part D, which is the semicircle. Same formula that we've been using, so we know that x squared plus y squared equals 64, which means that y equals the square root of 64 minus x squared. So with the semicircle, we know that we're looking at this, okay, where we know that the area formula is 1/2 pi r squared. Now, again, I want you to imagine that this is the x-axis, and these are points on our circle base. And we know that this is y, and we know that this is y. And since for this semicircle, all we need is the radius, we can see that since the entire base of this circle is 2y, then our radius is just y. So we plug that in right here, and we get that the area formula is 1/2 pi times y squared. I'm going to write out my integral from -8 to 8. I'm going to kick all of this out to the front, so pi over 2 out to the front. And then y squared is just 64 minus minus x squared. Again, do you notice what is underneath the integral here? The only thing you have to remember is what to put on the outside. So I'm going to put this in my calculator. Integral from -8 to 8, 64 minus x squared. And we get 1072.3303. All right, so just as a recap here, if you're dealing with a square, the area formula was 4y squared, and our integral was 4y squared. If we were dealing with an equilateral triangle, the area was y squared, square root 3, and our integral was square root 3 y squared. Ooh, equilateral. There you are. All right, if we were dealing with an isosceles right triangle, our area was y squared, which left us to just y squared. And if we were dealing with our semicircle, our area was pi over 2 y squared, which led us to pi over 2 y squared, where y came from the manipulation of the original formula for the base, which in this case was a circle. All right, that is cross sections. So you guys need to finish up pages 16 and let's look at 17, see what we got. Page 16 and where are you? Page 17. Yeah, give 17 a try as well. All right. Have a great Red Devil Day.